AP Cram, Calculus AB, Free Response Exam Review. Question 26, Linear Approximation. Okay, so grass clippings are placed in a bin where they decompose. For T is between 0 and 30 days, the amount of grass clippings remaining in the bin is modeled by A of T is equivalent to 6.687 times 0.931 raised to the T power, where A of T is measured in pounds and T is measured in days. For T is greater than 30, that is more than 30 days over a month's duration, L of T, the linear approximation to A at T equals 30, is a better model for the amount of grass clippings remaining in the bin. Use L of T to predict the time at which there will be 0.5 pounds of grass clippings remaining in the bin, and show your work that leads to this answer. Okay? All right, so I'll give you a moment to process this. For those of you who know how to arrive at a linear approximation, go ahead, and for those of you who don't, it's okay. The answer is coming soon. All right, so the key word in the question stem is linear approximation, okay? And in order to do a linear approximation, what we can opt to do is find the equation of the line, and then a lot of people like the slope-intercept formula, but in this particular instance, since we're given, we can figure out A of T for A of 30, A of 30 days, we can input that into our linear approximation. So what we're going to do is use the point slope formula, and that looks something like this. So excuse any time lag, y minus y1 equals m times x minus x1, okay? So, and then if we opt to, you can opt to bring y1 over to the right-hand side of the equation, leaving the y by itself. Okay, so that's what we're going to do. All right, so what we will ultimately end up with for a linear approximation after 30 days is going to be L of T, which, you know, our linear approximation of the amount of pounds that decompose at T, and T here is going to be, I don't know, greater than 30 days. It doesn't have to be, it's just a linear approximation. So we have A of 30, which we can figure out because we have the equation A of T. We can also figure out the slope because we can figure out A prime of 30, and our y1, no, our x1 and y, our L of, okay, excuse me, our x1 is going to be 30 because, you know, that information we can just plug into the equation, like I said before, okay? So, okay, let's figure out A prime of 30, our slope. Let's figure this guy out. And so all you basically do is take the derivative of this equation, which is going to be, you're going to factor out 6.687, and the derivative is going to be 6.687 times 0.931 over the log base 10 of 0.931. I showed this in a previous video, how to do this. So I think, I don't know, either video 24 or 25 of the series, check it out. And so you'll know where this comes from. And all you have to do to find the slope at 30, and you know this is just an approximation, is just plug in t equals 30 days, okay? And you'll figure out the answer evaluated at 30 days. Now we need to find our y1, which we brought over to the right-hand side as a variation on the, the general way the slope-intercept formula looks. So basically, when we plug in 30 into the equation, we get a of 30 is equivalent to 0.782928. Okay, so we found our slope, and now we found a of 30, and we didn't get a of 30 from the point slope formula. We got it from this guy up here, okay? We made 30 our t, our exponent. All right, now we're not entirely done with the question, because we're asked to predict at what time will there be 0.5 pounds of grass left over. So this would be our answer, our L of t. We're trying to figure out the t. And so now that we have a of 30 and a prime of 30, we could just plug in 0.5 right here. Sorry for the lag, I'm trying to make an arrow. Okay, there you go. And then solve for this t. Okay, and when we do that, when we let L of t be equivalent to 0.5 pounds, we get a t of 35.054 days. So that's a little beyond, the first day, maybe like the first day in an hour around 1 a.m. I mean, the 35th day around 1 a.m. ish.